Let us evaluate the integral of cotangent to the power 4 of x. When dealing with an integral of cotangent, you would first need to factor out a cotangent squared of x. Let's say this is the factored out cotangent squared of x, and the next step would be to transform this one into its trigonometric identity, which would be cotangent squared of x is equal to cosecant squared of x minus 1. And by that, let us replace it. Transforming this into its identity. And the next step would be to distribute cotangent squared of x among the parentheses. And the next step would be to split this integral into two parts. This should be the first and this should be the second, which is all multiplied by dx right here. Now that we have this one, we can now focus on the first one. Let u here, in this case, be cotangent of x. And the derivative of a cotangent of x would be equal to negative cosecant squared of x and multiply it by dx since it is respect to x. And what we need here would be isolate dx in order to replace in here. So dx right here would be equal to du over negative cosecant squared of x. By replacing that, we would have the value of u squared, since cotangent x is u and it is squared, so it would be u squared multiplied by cosecant squared of x and multiply it by the value of dx, which is du over negative cosecant squared of x. You can see here that cosecant squared of x would cancel, which leaves you with u squared multiplied by negative of du. You can actually put the negative sign outside the integral. So what you're left with here would be negative the integral of u squared of du. And it's just a simplification of integral. The integral of u squared would be equal to u to the power of 3 over 3 by the power rule. And now let us focus on the second part now. Wait, before that, we can put u back into its original form, which is cotangent of x. So we can say that the integral of this one would be equal to this one. And for the second one, the integral of cotangent squared of x dx. As we had said earlier, again, the rules of cotangent, whenever we're dealing with an integral of it, we would need to first get a cotangent squared of x, which is this one, and transform it into its identity. So by replacing that, this would be cosecant squared of x minus 1 of dx. And now we can actually split this integral into two parts. So the first one would be the integral of cosecant squared of x dx minus the integral of 1 dx. Remember that this is all multiplied by negative because of that. And now, let us take the integral of cosecant squared of x, which is actually equal to cotangent negative cotangent of x. This is because the derivative of a cotangent of x is equal to negative cosecant squared of x. And the opposite of a derivative is an integral. So we can say that the integral of negative cosecant squared of x is equal to positive cotangent of x. But since what we have here earlier is a positive cosecant squared of x, just replace the sign both ways. So you would have a value of negative cotangent of x. And now for the last one, the integral of 1 dx, it is simply equal to x. Plus c. This is the integral of this one. And now distributing the negative sign, you would have the final answer of negative cotangent cube of x over 3 plus cotangent of x plus c.